Hi, everybody. Thanks for coming to the YouTube streaming for the Greenplum roadmap update. We've got a huge community of Greenplum people, engineers, support people, customers, users who are all extremely working hard on Greenplum. And I wanted to take the chance to bring it all together and give you guys an update on what everybody's doing and where we're going with Greenplum here. So to set the stage a little bit, I've got slides here that I'm going to use. First of all, here's the legal safe harbor. Nothing said in here is a promise to deliver any specific features in the future. Obviously, the future is unpredictable, so things could change. This is our best intention viewpoint of where we are right now. So before I get started, I wanted to first clarify a few things. So sometimes people are confused between Pivotal Greenplum and Greenplum database. So the key point here is that Greenplum database is an open source project, right? It's based on Postgres. It's hosted in GitHub. So there's a whole bunch of code there that makes up Greenplum. All of the core of Greenplum database that you can compile and build into a working MPP database is part of Greenplum database. And then in addition to that, we've got a variety of vendors who take that core Greenplum database and make commercial offerings. So I'm Ivan Novick. I'm a product manager working at Pivotal Software in California, and we provide the Pivotal Greenplum product. So Pivotal Greenplum is one of the commercial products that's made up on Greenplum database, but I wanted to also recognize that there are other companies who are also providing their own commercial products for Greenplum database, namely HybridDB for Postgres, which is an Alibaba product based out of China. And there's as well ArenaDataDB based out of Russia, which is their own commercial distribution with their own secret sauce and their own special flavors for their product. And as well GreenDB, which is another commercial variety where they've put their own R&D and efforts in to build their own features on top of Greenplum. And there are others out there because now the technology is spreading a bit quickly and it's hard to keep track of everyone. These are ones I know people personally are working at. So for this presentation, kind of the reason I'm sharing this is to show that I'm going to be speaking on behalf of both what's going on in the Greenplum database, the open source world, but also from the Pivotal Greenplum point of view as far as what we're doing at Pivotal in our commercial offering and how we're going to be helping our customers and potential customers to use Greenplum more effectively. So with that, give you a quick agenda. So I'm going to give you a quick overview of how we think about Greenplum, how we're positioning Greenplum out there in the world, and then a review of the past releases. So what we've released in, let's say, the last year, plus or minus, for both the Greenplum database and Pivotal Greenplum. And then the roadmap of where we're going, what we're going to be releasing, and what we're excited about for the database, and then also for Pivotal Greenplum. So let's get started with the product positioning. So people will often ask, what is Greenplum? And using the word generically. And so let me give you my best explanation and positioning for Greenplum. So here what I've done is shown you a slide where you've got Postgres as an operational OLTP database and Greenplum is an analytical MPP. So really in the world of databases, it's divided into transactional and analytical databases where if you want to know, what is the specific attribute of one credit card transaction that's in a database, you would go and look it up or update it in the database. That's transactional. If you want to see a trend of credit card transactions over 7 years, that's an analytical query. So these are two different workloads, two different use cases. So really Greenplum is that analytical use case and Postgres is that transactional use case. But the idea is that both of them have a similar look and feel. And Greenplum is based off of that Postgres code base. I still have not defined what is Greenplum. And the way I'd like to define it today is that Greenplum is redefining the data warehouse. So a data warehouse is where you store huge amounts of historical data, you do analytics and queries. But it also has a bit of a bad connotation People think of the data warehouse as something that's hard to get access to, something that special administrators have that's very expensive, that's proprietary. So at Greenplum, we're bringing all of the attributes of data warehousing, but we're trying to redefine it to not be that expensive, proprietary, isolated environment, but part of your ecosystem inside the company where it works with all the open source technologies and that it can grow based on demand, not based on limited by cost, really. So in addition to that, because Greenplum is based on Postgres and has this concept of inheritance and extensibility, that allows us to build a data warehouse like's never been built before. So the ability to integrate all kinds of third-party libraries from the open source, Python, R, text analytics, machine learning, geospatial analytics. This is how I think we can redefine what a data warehouse is for the world. The note here is it's not a scale-out OLTP. So if you're looking for a way to take Postgres and scale it out to do a scale-out OLTP, that's not what we're doing, right? We're building one unified large database for processing analytical queries and for running kind of more of a reporting and intelligence workloads on it. Okay, so where we're standing and how we position ourselves is also impacted by the competition. So if you look at the DB Engine ranking, which is a nice website that has, I think, a fairly scientific method of polling social media and job listings and the web, basically crawling the web to find out the popularity of every database in the world, we can look and see how we're standing in terms of success. And there's 350 total databases on DB Engines. 140 are relational. And of all those, we're ranked number 23rd for relational. And of those 23 that are ranked 22 that are ranked above us, about 8 of them are completely irrelevant, like Microsoft Access, things that have nothing to do with big data, right? And then the ones that are still there that are kind of leading us in terms of popularity, it's heavily huge companies. So if you look at Oracle, SAP, IBM, Microsoft, Amazon, and Google, you're talking about an average, company vendor size of, I don't know, $200 billion, right? And you're also talking about pretty much all vendors providing proprietary technologies, closed source, proprietary, and often tied to very specific environments, right? So if you're looking at a data warehouse from Amazon, you're going to be looking at pretty much running it on Amazon. And it's going to be closed source, and it's going to be proprietary, right? And so pretty much all of the vendors there, the one that I've left there as the exception is Hadoop. So Hadoop is also open source. And so I think there's still a lot of people in the market trying to figure out, when do you use Hadoop? When do I use Greenplum? And what we've seen is that Greenplum has really picked up momentum as kind of some of the, let's say, unfair euphoria for Hadoop has kind of settled down, and people are looking at what can these technologies really do. They're seeing that because Greenplum is really based on a relational technology, a true database technology, that it can perform SQL and mission-critical performance in ways that they're not getting elsewhere. So I think we're really positioned here as a leading open source big data analytics software in the world right now. And that comes from that natural relational heritage. It comes from the ability to run true petabyte scale based on Postgres and the track record, right? It takes 10 to 20 years to mature a database technology, right? Postgres, Oracle, these things have been out for what, 30 years, something like that, right? And if you come out with a new database technology, completely new, and expect it to be successful within 2 or 3 years, you probably need to add another 1 or 2 decades to your expectations, right? Before it can really become good. So we've been out there with Greenplum now for 15 to 17 years, and are starting to really accumulate that track record of mission critical availability and performance that where there are industrial, financial, and government customers around the globe who rely on this for their, the operations of their industries. So with that, that's the context here. So we have this opportunity to continue to push forward based on a very strong base. Greenplum has a very strong base of users and usability for big data processing. We have that opportunity to push it to the next level. So let's talk about what have we provided in the recent releases, and then we're going to go into what's coming in the upcoming releases. So starting with Greenplum 5. Greenplum 5 was the first open source Greenplum. It came out in 2017 of September. It was the beginning of our march forward in Postgres integration. So we did our first Postgres merge, as we call it. So a Postgres merge means take all of the code from a specific version of Postgres and very intelligently reintegrate it back into Greenplum. Because when Greenplum was created, based on Postgres, we were based on Postgres 8.2. So we're now a large way through, I would say more than 70% through, reintegrating all of Postgres back into Greenplum. But Greenplum 5 was based on Postgres 8.3. It reintegrated 3,300 patches into Greenplum. It brought in JSON data types. It brought in several other semi-structured data types, so you can do both structured, semi-structured data. We'll talk about unstructured data as well. And then a whole number of performance enhancements that came there with Analyze, the way that Analyze is approached, with the optimizer, we're going to talk more about that, and with the resource groups, we're going to talk more about that as well. So in terms of the resource groups, what this provides Greenplum, and this is actually a really nice innovation on top of the core Postgres. So in core Postgres, when you run a query, every query is a process, right? And once that process starts running, it runs. It runs as fast as it can, right? Now, that works out well in an OLTP context, but in an analytical context, a lot of times when you ask the system to run a query, that query could take a long time, and it could take a lot of resources, right? You could be saying, you could be asking someone to calculate 100 scenarios across 10 years worth of credit card transactions or off of petabytes of data. So the point is that when you ask an analytical question, you could be asking it to run a huge number of calculations. And as you add concurrent users, how do you control the system so that you just don't flat out run out of resources and or start uncontrollably slowing down queries that didn't expect to be slowed down? So what resource groups does is it allows you to launch processes into predefined operating system swim lanes. Right? You can create swim lanes in the operating system with something called C groups. And that allows it to let the operating system restrict how much is available for those processes to run very clearly or very strictly and at the OS layer. So instead of if we launch 1,000 queries at the same time, and a lot of them are complex, well, instead of them all just fighting over all of the CPU resources, the queries can be running within their swim lane and be allocated. Okay, you've got 2% of the CPU. Now go crazy, right? So that process, when it starts, it'll be running and tagged by the OS saying you're part of this group. So this is another way to control the processes, something that didn't exist prior in Greenplum and doesn't exist in Postgres because they're primarily used for OLTP and allows us to run extremely large, robust workloads that are complex and under tight control. The next bit is that we've been looking back again over the last 1 year is the GPORCA Optimizer. So what the GPORCA Optimizer's goal is to be the unbreakable data warehouse SQL optimizer, right? Where you can have a large-scale enterprise could throw 1 million queries at it of completely complex nature, and for the database to just take them in one by one and say, okay, got it, I got it, and to do very efficient query optimization across the unpredictable nature of any possible SQLs, right? So in 2018, there's a number of very technical and important improvements that have allowed us to bring up more and larger, big enterprises to run full-scale systems on Greenplum with hugely diverse and complex SQL. So in particular, we have introduced the new analyze to Greenplum in the last year. So with this, we use hyperlog-log, and hyperlog-log allows us to very rapidly aggregate in the new statistics as new data is added. So you can run analyze. Analyze now could be run in just a couple of seconds instead of having to scan all the data and taking a long time to do sampling. And it can basically aggregate those statistics for the new data in with the old data. So this allows us to keep current statistics about the most common values and the histograms of the values current without very CPU or resource intensive loads in order to keep the statistics up to date. And without the statistics, we wouldn't know how to create the most optimal plan. So this is a huge improvement over the last year. Also, when it comes to optimization time, so it's great, we can create a great plan, but how long does it take to come up with the plan? So basically, when a SQL comes in, there's a trillion possibilities of ways to execute it, right? And we need to consider every possible way and find the lowest cost. Is that even possible? And if it is possible, how do you do it without having the optimization itself take longer than executing the thing in the first place? So we've introduced additional caching and additional early space pruning into the process over the last year so that we can carve the search space of potential plans sooner and keep the optimization time down. So we're always watching not only how good is the query, but how quickly can we come up with the plan. We're also able now to handle very large table joins. So you could combine many tables in one query and not be afraid that the optimizer is not going to be able to handle it. And we figure out the correct join order or the optimal join order using a variety of algorithms. In particular, we have now introduced a greedy algorithm. Greedy algorithm is something you can Google. It's on Wikipedia. It's a way to, you think of, if I want to go from New York to San Francisco, do you consider just the first random path you pick, or do you consider choosing every possible path, or do you use some sort of smart approach to go through this area? So greedy algorithm, something like that. We use that in the join order selection to help us to get efficient join order, which is really important to get a good performance. We also, traditionally with Greenplum, the recommendation was don't use indexes, right? We said, look, you've got Greenplum, put all your data, we'll figure it out, just run the query, right? And we'll scan the data fast because we're fast. Then we came back and said, well, but if you want to do a quick lookup, then you could put an index on it and we could do 50,000 or 15,000 quick lookups a second. So you can do, let's say, look for some special drill through query into some ID. Now, in the latest one, we're saying, look, we can actually use the index a bit in certain cases. There are certain cases where indexes can help us, even in data warehousing, which is new for us. And this, you can think of a case where you've got, let's say, a medium-sized table with an index, and then you're combining it with some much bigger tables, and you've got high selection criteria on the table. The index can actually help us to run the query faster. So we are now able to leverage indexes more than we ever have, including geospatial indexes, like GIST indexes, through the GPORCA Optimizer. And let's see, cardinality estimation is something optimizer people are always talking about. We have continued to improve cardinality estimation, especially for left joins, predicates on text columns. And as well, I think that we are very good at complex nested subqueries. So all kinds of correlation and subqueries and these kinds of things traditionally have thrown new databases through the loop. They were hard to do. They would end up doing brute force approaches to solve these, and the queries would run forever. So we continue to improve that. We optimize for collocation as much as possible so that when you're running that, the processing is happening between tables locally, and have all of these things together mean that you can take a huge company running extremely complex workload and be confident that all of the queries are going to run well, right? And we're going to continue to work on that. From the backup side, we've completely reintroduced the backup program in the last year. So the GPBackup is the replacement for GPCron. And this uses a new Greenplum feature in the last year called copy to segment. So you might be familiar in Postgres with the copy statement. Copy means take the data and then export it to, let's say, CSV, and bring it back to the client to dump it to a local file. In Greenplum, we also have copy to segment, which means go to all the parallel segments, and instead of bringing the data back to the master, just have it be exported locally. So you can issue a copy command from the master, but it will actually be exporting locally in parallel to all the segments. This is a way for us to run a valid SQL command with ACID semantics, but to have the data exported to the local file system in parallel fashion. This allows us to meet our goal, which is to provide a data export tool for data protection. So it's a full data export. There are multiple forms of backup. GPBackup is a data export, right? It's not an internal snapshot tool. And it allows you to get the data out of the database rapidly while the system is running online. It has a very low lock profile. So for the people who want to run your ETL while you do backup, or who want to do processing while you do backup, it's very important that we don't sacrifice availability by taking catalog locks or any huge locks on the system. We act like a user, and we come and select data and take normal locks like any user query. It also comes with differential backup, so that, for example, you've got this huge historical database. Let's say I run a retail chain in, let's say I'm the retail chain of Antarctica, and I've got 5,000 stores. And what I want to do is I want to store the history of every purchase. But this is a future world where Antarctica has lots of people. So I want to store the history of everything bought at all the retail stores every day, right? And I want to store that in partitions. Well, what's going to end up happening is the old days are not going to change because those purchases are done. So what you want from a data export tool is to automatically detect any of the partitions and tables that are modified and export those, but be able to just symlink in the unmodified previous backup data. That's a differential backup, and that allows you to work with big data sets and to do backups efficiently. We also have plugins, so you can directly back up to S3 or to your proprietary setup using a plugin. So we can feed that data through the plugin to your own source in parallel, to your own destination. From the procedural language point of view, so the context here is Greenplum is a database, right? It's a SQL language interface. SQL is the structured query language for operating on sets of data, right? It allows you to select from sets of data. That's the concept of relational database. Now, in addition to that, like many other databases, we have a concept of embedded procedural languages. So procedural languages are not set languages. They're your typical programming language you learn in college where you do for I equals 1 to 100, do X, right? And then end. You just go from beginning to end. So there's a whole bunch of procedural languages like Python, C, Perl, Java, R that you might want to use to process data that's in the database as part of your workflow. And this is very important, especially for data scientists who want to leverage the libraries that come with Python and R to be able to have access to these kinds of things. So what we provided in the last year is a way to Dockerize this environment, to be able to say to a developer, you create a Docker container with Python with all of your stuff in it, with all of your libraries and modules, push that out to the cluster, and then you can process the data in the database in parallel by feeding it live through the Docker containers as you process it. So that the developer who's writing the analytics can write it and can control their environment and have it be separated from the database and the DBA without having to ask them, can you install all these things? It also allows us as a DBA to control how much resources the developers get so that Docker container can be limited in space and in resource usage, and it can also be contained in what they can access. So let's say I give my friend, the developer, access to run Python, and the first code they write is sys.execute, and then they execute some command, and in that command it says sudo rmrf/foo, right? So that would not work in a container because the container would block them, right? So the container allows us to provide a professional environment for Python and R development in the context of huge data sets in parallel. So now coming to PXF. So PXF is how we can do query federation and how we can access data in external systems that come from the entire data ecosystem that you're working with. So what this leverages in Greenplum is a feature called external tables. And it basically allows you to query Greenplum even if the data is living outside of Greenplum. So let's say, for example, back to my Antarctica empire of stores, I might decide that, OK, every year of data I'm storing is 50 petabytes or 20 petabytes. I can't afford to store that all in the database. So what I'm going to start doing is offloading some of these data sets into an object store or into HDFS. But I can still query it in Greenplum if I have network access by using PXF. So the way PXF works, it's a plugin that goes into Greenplum, and then you create a reference. You create an external table. You point it at where the data is. And then when you query that table, instead of it scanning from local disk, it'll actually do remote calls to wherever the data lives. So PXF can directly query to Hadoop, can query to Hive, HBase, and then for those, we support the file formats that are natively stored or natively used by the Hadoop system. So we can read Parquet files and Avro files and things like that. You can also now, as of recently, actually this month, you can now actually directly access the data in S3 object stores as well. And it can also be in these advanced file formats like Avro and Parquet. So you can query directly to Greenplum, and then the data could be living in S3 or in HDFS. We also have with this some advanced features. So you can do it can do smart scanning. If that data is all in the object store and you've got 500 columns, but your query is only for one column, well, wouldn't it be better if we didn't have to download all of the columns, right? Or if you only ask for a certain rows, can we not bring back only those rows? This comes in big with the RDBMS connection, which I didn't mention. So you can actually reference another database like Oracle or Postgres or even another Greenplum, and then query to local Greenplum. It'll go and do a remote query to another database. And then with this predicate pushdown, we can filter it so that we don't even bring back the rows to Greenplum except for the ones that match the filter. So it makes for efficient access of a remote querying. On the analytics side, we work in strong partnership with the Apache Madlib projects, part of the Apache Foundation. They have a full set of library of analytics that work natively in Postgres and Greenplum. And the big project we did in recent times was graph analytics. So in Greenplum, you can do graph analytics. And this is helpful because the value of analytics is frequently from the combination of things. It's very frequent that one tool is going to give you all of the things you need for some job, right? You might have some graph, but you might also want to do some traditional SQL, some machine learning. You can bring all this together in one big, powerful database. And it's very simple. So here, we have a PageRank function. PageRank, let's say you've got this complex graph, all the websites in the world, and you want to calculate PageRank of everything. Well, I don't know how to write a PageRank, but I know how to call this one function. Select madlib.pagerank, point it at the table, and then get the results in a result table. So you can kind of offlift the implementation of graph algorithms, but get the benefit to be able to use the algorithm to get the analytical insight. And all of that just natively in the Greenplum database without having to do anything tricky. OK, so all of that stuff is all open source. That's all things that come in the community. That's the Greenplum database. That's Apache Madlib. And what I want to also now do is mention on the pivotal Greenplum side some of the things we've brought to the market for users to help them in recent times with their systems. So number one is the command center. So in the command center, we have a completely refreshed and rebuilt command center. It's the single pane of glass where a Greenplum administrator goes to see what's going on with their system, right? And it has in there all of your health indicators, all of your, it shows you the running queries. It shows you can get warnings there. Okay, this query is blocked on this other query. It has, you can click on the query and see a visual explain plan of it. And if you're running a long query, let's say a half-an-hour query, you can actually see what it's doing. For example, you might go and say, oh, it's stuck here doing sorting, and it's been sorting for an hour. Why is it doing sorting? What is it about my query that I even care? Can I even change this query and somehow get rid of the necessity for sorting, right? So this allows you to get the insights into the system and see what it's doing and to improve your queries. You can also control workloads through this thing. You can set up your resource groups. You can configure who gets access to what, how much you get access to, set up permissions, and set up your swim lanes to allow, let's say, ETL to get certain slice of the system and ad hoc users to get another slice and your data scientists another slice. You can configure all of that in this single pane of glass and be able to control it. Now, from the point of view of data loading, Kafka is front and center for us, and I think largely for large percentage of the industry. So Kafka has brought, from my viewpoint, Kafka has brought a level of scalability with a level of data integrity and auditability that we haven't seen before Kafka. So the idea that you can take, I have a colleague or customer actually who processes internet data, right? So internet data, it's like you're tracking everybody's clicks and views across huge portions of the internet. So petabytes of data coming. What they need to do is to have a way to push that data as it comes at extremely high rate and to capture it all. They were actually previously pushing it into HDFS, but HDFS was dying as they were trying to push it in. It couldn't keep up. In addition to that, I've got another friend and colleague at a stock exchange, and they want to be able to track every trade, capture it as it comes, and be able to ingest it all. But in their case, it's extremely important not to lose even one message, right? So the fact that Kafka is like a distributed log, it's almost like blockchain, but has a use. Yeah. So this technology has really changed a lot, and most of the enterprises I talk to are looking at Kafka for their data ingestion and data sharing approach. So we, of course, have jumped on that at Pivotal, and what we provide is peanut butter with jelly. So these two things match together. Kafka does not do anything Greenplum does. Greenplum doesn't do anything Kafka does, but they're peanut butter and jelly together. So basically, you can have continual data loading. Data can be fed into Kafka at any speed without losing one bit of data. And then it has continual loading from Kafka into Greenplum. So as the data is going into Kafka with a short delay, it will then be pumped into your Greenplum database where you can do large-scale queries and analytics in it across all of the data. So it's always updating. Your Greenplum's always updating based on Kafka without hackery or special coding to try and create mini batch jobs where you say every 1 minute get some flat files and run a job and then check the return code and then move those files to the I'm done directory except the ones that failed and then rerun those. None of that, right? It's a industrial strength, always loading, always updating system that just runs. And if it fails, you can just resume it and it will just pick up where it left off. You don't need to even understand where it left off. You just restart it and it tracks what was the last offset that was committed and pick up from that place and continue. So it's always updating, and it can be guaranteed, strong consistency guarantees of getting every bit of data once. Our integration is Confluent certified, and with that, we also support various data types like Avro, CSV. Avro has fancy things so that you can do schema evolutions. So as the schema changes for the data, you can continue to bring in data into Greenplum. We can do transformations on the data as it's coming over to Greenplum. And then also now we can do automated aggregation and maintenance jobs. So imagine in the database, you're getting in all this data, but you want to have ready to users a roll-up, some sort of, hey, what was the average sensor value that we received in the last 25 minutes or the last half an hour, right? How can you have ready for them an average without every user running an average query? We could pre-generate these queries by having SQL attached to the Greenplum-Kafka integration and automatically re-aggregate data periodically as it's coming in so that users can just see an always updated aggregation of the data. So this is very exciting and available now. Also, the text integration. So people who have a huge percentage of data in the world is human language, right? It's not just fitting into rows and columns. And in fact, when people talk about structured and unstructured data, a lot of times when they talk about unstructured data, what they're really talking about is human language, right? There's also images and videos, but human language is a huge percentage of the unstructured data. So as we're redefining the data warehouse with Greenplum, we're including human language as part of the domain and saying that you can store in text columns human language text, and that we have the ability to do smart indexing, querying, and analytics on it, such as using natural language processing to search for, to distinguish the word jobs as the last name of a person from the word jobs as how many jobs were created in America this year. That's a clear distinction that can be made using natural language processing, and we can index and query based on these understandings and create an advanced data warehouse that has more rich context. And really, I want to say, when people ask, they ask about artificial intelligence and where is the world going with AI, and the first thing someone not in the computer field thinks of is like some sort of autonomous robot that Terminator or something that comes to their house and takes care of the house for them, and they come and talk to them, hey, Mark, how's everything going? And the Mark tells you how your house is. But that's let's call it an artificial person, right? But artificial intelligence in reality, one of the first things you need to do is to take all this information that's out there, find patterns in it, but also to be able to understand human language. So bringing this together, we're building more and more of an infrastructure people can use towards building artificial intelligence and smart software. We also have, with the Pivotal distribution, a Spark connector. So anybody who is a Spark, dedicated Spark user can access data in Greenplum, and we could keep it centralized as the single source of truth in the Greenplum database. People can query through SQL, or they can access it with Spark if you want to access it through Spark. And then lastly, I think on this section, almost lastly on this section, a couple more things. We've been busy, so bear with me here. GPCopy. So GPCopy is your data migration tool. How do you bring data from one cluster to another? So in today's world, in reality, people have not just one Greenplum cluster. They tend to, the more successful they get, they'll end up with 50 clusters. Different departments, they'll have different areas of the business with their own data sets. They could have test systems, QA systems, end up with 10, 20, 30, 40 systems. And GPCopy allows you to move data from one to another, independent of cluster size, independent of database version, allows you to do migrations and to move stuff where it needs to be. From the cloud side, the public cloud side, we have introduced ready-to-go push-button environments in all of the major US public clouds. So Amazon, Microsoft, and Google, you can do push-button deployments and get a fully featured Greenplum environment with the benefit of Pivotal's tuning. So we tune the whole cluster and setup so that it's ready to go for production usage. It also comes with extra tooling, extra features and capabilities that can take advantage of each individual public cloud environment, like if any features that they have that we can use. So that's something to take advantage of if you really want to run your stuff in the public cloud. Okay, great. We got through the recent accomplishments, so now we're going to move on to the Greenplum database v6 roadmap. So Greenplum database, the latest is 5.16, and 6.0.0 will come out this year. We're going to go into beta, I would say, within about 30 days from now, and then probably about 90 days of beta, and then we'll go GA, rough and tough. This release, Greenplum 5 has gotten a huge adoption on top of where we were with Greenplum 4. And I think Greenplum 6 is the opportunity for us to really break through into a much wider market. So actually, the first thing I want to say about Greenplum 6 that's not on the slide is that Greenplum 6 will come with binary packages that can be easily installed on, let's call them traditional enterprise systems like Red Hat, CentOS, et cetera, so that we can make it, we've always offered with open source the ability to compile your own system, and we've offered with Ubuntu the ability for people to have a precompiled version. But now with Greenplum 6, we see everybody wants that precompiled version, which is hey, here's your free software ready to go, right? And so we will have free binaries for Greenplum 6 with this release. It's based on Postgres 9.4. So one of the interesting things about Postgres 9.4 is that it's actually still a fully supported version of Postgres. So this will be, when you run Greenplum, it's running a fully supported version of Postgres. Now, we've become experts in the Greenplum community and Postgres and how to work with the various versions, but it is good to see that we are running based on a fully supported version. It also, based on the fact that it is Postgres 9.4, it's going to be a massive improvement in our ability to integrate with third-party tools and libraries. So things that work in the Postgres environment will more easily just work out of the box with Greenplum, which again helps the whole ecosystem that we're working with. Some of the capabilities that came from Postgres merging that end users might find particularly interesting include, it has column level permissions. So you can set your permissions, say, okay, I don't want the credit card column to have permissions for the average user, but they can see all the other columns, right? There are actually, in Postgres 9, roughly around 9, they did actually create a number of interesting improvements to the permissions model. There's a number of additional functions and usability features around how you can alter some of the roles and set permissions. So this is going to be a better from the end user point of view in terms of permission management. Recursive CTE is not going to be in, actually. It's still going to be a experimental feature. We're working hard on it, and there's very few of the vendors who have this working. It's a tough challenge, but we will get it in the future. It was hopeful for 6, but I don't think it's going to get there. GIN index support. So GIN index support will help us with full text searching. So you can have native text columns in Greenplum, create GIN indexes on JSON or on text, and be able to do, it's an inverted index, so it allows you to find things quickly natively in Greenplum with the GIN index. Range types are extremely interesting to business users and data scientists. So you can have one data type which represents a range of values. And that's something new for Greenplum, but came from Postgres 9.4, or one of the Postgres's in this series. And I know there's folks looking to use this for IP ranges, network IP ranges. There are various data types where you can create date ranges. And then it gives you a more sophisticated way to model certain problems. there is now a foreign table concept. So we've had external data in Greenplum for a while. Postgres has this idea of a foreign table or foreign data source. And we now have this in Greenplum. We will be using it more in the future. But as a general concept, it's there in Greenplum now. JSON-B, which is a performance improver for Greenplum, is there in Greenplum 6. And in total, over 10,000 commits have been merged. As far as write-ahead logging, so write-ahead logging is it's actually a very fundamental point to Greenplum 6, so not to be taken lightly. So essentially, at the core of the storage layer, how do we track changes in order to provide high availability and to provide mirroring and to provide various forms of data replication? Write-ahead logging is new to Greenplum. It came from Postgres. We used to have in Greenplum another approach, which was file replication. But this write-ahead logging will allow us to have more granular and robust solutions around data mirroring, data protection, and eventually data replication. A couple of other really key points here. So we have Greenplum 6 has a concept called jump consistent hash. So if you look at how data is divided between the machines or between the Postgres instances in Greenplum 5 and before, it's very simple. You basically pick a column or a set of columns, you hash that and get a hash number, and then you take a modulo, right? Modulo means divide and get the remainder. That remainder is the location where that data set lives, right? There's no name node where we track all the blocks. You just check that row and then figure out based on the algorithm where it goes. It works great. However, we have a better way to do it now, which is going to mean that cluster size changes can be more efficient. So instead of just taking a modulo, we can do jump consistent hash. And what that means is that it's an algorithm that optimizes for minimal changes as the size of the cluster grows and shrinks. So if we go from 100 servers, let's say to 102, then when we expand, what we expect is 2% of the data to be remapped to the new additional servers. Instead of, if we relied on modulo, all of the data would be reshuffled based on a new modulo, right? So instead of 100% data movement, we're doing 2%. So we've just made this cluster size change 50 times faster, right? It's a big fundamental impact. The replicated tables allows a user to designate a table that should be stored repeatedly on every segment. So in data warehousing case, let's say that you have we have this thing called dimensions and fact tables, and when we do star schemas and things like that. So if you have a middle-sized table, let's say it's 50 megabytes, and that table, instead of dividing it up and putting pieces of it everywhere, if that table is going to be joined in a huge query against all the rows, by pre-broadcasting that to every node, that means that when you do a join, it's completely local. So that 50 meg is just sitting there in memory, probably in memory after it's cached in, and then you can just loop through and process it in parallel. It can allow for extremely efficient big performance gains in data warehousing use cases. And looking at other use cases, so we are completely focused on big data use cases here. But what we found in the real world, what I found in the real world, is that in real world big data use cases, data warehouse use cases, analytical use cases, some amount of OLTP is required in real projects, right? Whether it be tracking tables or integrating in some set of data that needs to be updated frequently, it's idealistic to expect that, hey, we'll do all of my big data querying here, and then I'm going to have this other database for OLTP. Well, that's great. If you're fully doing an OLTP workload, you should put it in another database. But if you have a mixed workload, it can be very inconvenient to have to push off your OLTP to another system. So what we see is the ability in Greenplum 6 to get massive OLTP performance gains by the global distributed deadlock detector that's been introduced in Greenplum 6. And this means that you can integrate your mixed workload to have both warehousing with some amount of OLTP in the same environment. Two more big ones, part of this Greenplum 6 release, are the compression algorithm, the Z-standard compression algorithm, which is faster using less CPU than the algorithms that we've had in the past. It's from open source. It's one of the most popular algorithms. But time is money, right? And CPU cycles are money. And if we're wasting CPU cycles on compression when another algorithm could do the exact same thing faster, just thrown money down the drain. So Z-standard compression is faster and slightly more efficient, more compressing as well. So that makes a big deal. So when you go to Greenplum 6, you're using less cycles for repetitive tasks like compression. And lastly, disk quotas, which is really important for environments, let's say exploratory data science environments where people are need to create scratch space and reserve a certain amount of space, and they don't want them to fill up the whole disk because they made a mistake in their SQL and generated a huge cross-join and filled it up. So these quotas will be very helpful. Okay, so wanted to also share with you a couple of the items which could not be completed for Greenplum 6, which will then become the foundation of Greenplum 7 in 2020. So not 2025. We're planning to turn around in 1 year after Greenplum 6 and release Greenplum 7. Okay, so 12 months later is our goal. And what we're looking at here is a minimum of merging in Postgres 9.6 into Greenplum. So Greenplum 9.6 comes with a whole bunch of fun stuff. Some of the fun stuff it comes with is upsert. Upsert means insert, but if there's a conflict, then update. Extremely useful for day-to-day users. Row-level security, extremely interesting for government users and people who have these complex security requirements. Brin indices, which are block range indexes, which allow you to store the min and the max value at a block level and skip the I/O as part of your query processing. So this is a performance feature very similar to people who are familiar with things like zone maps, similar to like a zone map, which will come into Greenplum through Brin indices. And then Postgres 9.6 also went down the beginning of the journey of parallel execution. So historically in Postgres, one query, one process, one thread, right? But with Postgres 9.6, the process has begun to do more parallelization. So interesting things that can come out of this are things like to dynamically do parallel scanning. So if we had a partition table with 8 partitions and we want to do the query, maybe we can scan all 8 partitions in parallel, bring that together. So there's opportunity there. The other ones of particular interest are hardware-assisted snapshot and disaster recovery. So right now, there are many cloud and hardware vendors that know how to take snapshots. But the key with Greenplum is we need atomic snapshots. If you want to take a snapshot and bring back the cluster from a snapshot, it needs to be done on all of the machines at the same moment, which is, of course, not possible unless the hardware provider can do that, and most hardware providers cannot do that. So what we're looking at in the future here is to embed the intelligence into Greenplum so that even if the snapshots are taken asynchronously by several seconds here or there, that when we bring back the cluster, we have enough breadcrumbs to piece it together and bring back a completely atomically whole state of Greenplum that is valid. And that would allow us to bring a future direction of integrating with hardware vendors and cloud vendors to easily snapshot and replicate Greenplum databases all over the place. Also looking to automate the failover of masters processes so that traditionally a role reserved for DBA, but to do this automatically. The ability to shrink clusters, and then also very exciting, the ability to query between multiple Greenplum clusters with foreign data wrappers. So I've seen a demo of this just last week from some developers, and what it means is that you can create a query plan where as part of that query plan is a foreign scan. And it can do all kinds of smart things, right? It can operate on the remote cluster to do the parts that are efficient there and bring back the necessary data, but really to say, okay, I've got a 50 server cluster. Actually, I have 4 50 server clusters, and I don't want them to share any data. They all have their own data, but sometimes I need to query the data from here and there together. And it allows us to create another layer without actually a complex feature, but we can say we've got multiple Greenplum clusters, but still kind of make it seem like one Uber cluster in a certain sense, because you can still access all the data. So you could have, let's say, 5 clusters of 200 servers, which is really 1,000 servers, and take advantage of it as needed. There's a lot more will come. That's what's known so far. And I think with that, I'm going to pull the plug on it and say, look for Q&A. So I'll just jump to the last slide here. There's a whole lot of stuff which I didn't have time for. But the conclusion is, make sure that you go big and make sure go green. Okay? So with that, any questions from the YouTube? Nothing? Anyone here? No? OK. So thanks a lot, everybody. I hope you enjoyed the presentation, and take advantage of everything we're working on. Appreciate it.